discuss through today?
Problem set, it's going to be 8-7, number 23.
Okay. Textbook right here. All right. 8-7-23 says the following. Use the method described in number 20. Okay. So pretty much 23, the reason it's hard, I think a couple of you asked this. Were you at office hours when we went over this?
We went over a different one from the homework.
Okay. But similar, right, nature?
Yeah.
So talk to me, Jim. Where were you a little bit confused? What was the issue you ran into?
So I did the synthetic division, and I found my,
Well, what did you do first, Jim?
Okay, so I took the P over Q, and the factors are 1 half, 3 halves, 1 over...
Now, before you did P over Q, though, Jim, what did you do? You can't do P over Q, right?
I multiplied by 3.
Good. So everybody, by 3?
Or 6.
Multiply by 6. Why 6?
It's the least common factor.
Least common multiple of the denominators. Good. 6 is the least common multiple of the denominators. So to clear out all fractions, please multiply by 6. 6 times a third is 2. 6 times a half is 3. 6 times 2/3 is 4. And 6 times 1 is 6. Okay, Jim, continue.
So then I took my P over Q.
Okay, got it. What were you given?
You get plus or minus 1 half, 3 halves, 1, 2, 3, 6.
Okay. Keep talking to me.
And so then I did synthetic division. I got on the top 2, 3, 4, 6.
What'd you test?
I just went through a bunch.
And what was the concern you had?
Where then I ended up with -3 over 2.
That's the one that worked, you're saying?
Yeah.
So -3 halves works. What do you get as your row?
2, 0, 4, 0.
Okay.
And
Depressed equation. Go ahead.
Yeah. Then your depressed equation, I did 2, 0, 4. This is where I get kind of confused then, because when I put in the depressed equation, it's not a factor. You have a remainder in there, so I don't really know what to do with
Oh,
that.
careful. What do you mean you have a remainder?
When I went back into the depressed and retested.
You mean you use -3
Yeah.
So remember, if your depressed is quadratic, you don't test again.
Oh.
You go right to quadratic formula or factoring.
Okay. Yeah.
So I would have subtracted 4 divided by 2. You'll get x squared equals -2. So x will equal plus or minus √2 times I. You follow what I'm getting at?
Yeah.
Okay, so write yourself a note that as soon as you get down to a quadratic, either factor or use the quadratic formula to get the other 2 roots.
Okay.
Okay, did -3 halves work? Just check Jimmy's work. Did others do this yet? Agreed? Okay. So I want to make sure there's no mistake somewhere else that caused it. So -3 halves is one of my roots. Set the depressed equation equal to 0 and factor or use the quadratic formula to get the remaining 2 roots. The other 2 roots, we just said, what kind of roots are they? Imaginary. So if I were to graph this function and I set it equal to f of x instead of 0, and I know it's equal to 0, so it's not a function, but hypothetically, had this original equaled f of x instead, this is a really interesting graph because look, -3 halves would be my only root right there. That'd be my only root. My y-intercept would be 1. So I can plug in my y-intercept of 1 and -3 halves as my x-intercept, but that's it. That's all I can really plug in. Now, because it's x cubed, there's a chance that you're going to get like a little min or a max somewhere, a dip. So you'll notice like for a graph like this one, let me think. This graph has to end this way, and this guy has to continue this way. Now, it could do this in the middle. It's possible. Or technically, let me draw another graph so you can see it. Or it could do this. Where there's no actual dip there. And that happens sometimes when there's no extra loop in the middle. So what would be a nice technique or a nice thing to look at? I would probably, if it were me trying to graph this, I'd probably figure out some of the coordinates here. Maybe like do f of -1 and f of 0.5 to see if these are the points, or if these are the points like that to see the curvature. So between this root and the y-intercept, maybe plot a couple points. And right after the y-intercept, maybe plot 1 or 2 points in case we want to look at that. Because this is a weird function, right? We can tell with only one real root, when it's cubic, it's tough to estimate what the graph is going to look like without a calculator. So consider plotting appropriate points. And by appropriate, it makes sense to use points in here or right outside of the roots or the y-intercept. John?
And by plotting points, you can just plug a value into the equation and then the...
Yeah, or just run it to the table, John, like this. Plug a -1 in. Don't you get out the y?
Oh, yeah.
It's so much faster to do synthetic substitution by plugging into a table. Now, here's the thing. Keep in mind that we multiplied this entire equation by 6, didn't we? So if you get an answer here, take a look. If you get a number that comes out to be 12, it's not 12 on the graph. It's really just 2. Because we multiplied the original equation by 6, right? So you got to take this y value you're going to get out and divide it by 6 instead. Okay? Listen, before you all run, because we're not in too much rush, it isn't be that. If you want to hang around for like 10, 15 minutes and talk with me about this for a little bit, that's fine. Because I know we had a little bit of a rush period. Obviously, your test is still tomorrow. It's the last day before break. Everybody, look at me in the eyes. Everybody will be here tomorrow. Agreed?
Yeah.
Right? Everybody?
I might plan to be sick.
We know if Franco's sick or it's absent.
I can fight.
Because if you don't take this test, it has to happen the day you get back. You're going to be cold on it, and then have to grade it that night to get the grades in the next morning. Technically, the grades are due when we get back. But if you miss, you'd have to take it the minute you get back, or you're going to overbreak something. So please, don't miss school tomorrow. Okay? All right, hang out if I ask a couple more questions. Okay, good. He has a quick question. You can hang out? Yeah, you're here right now. So what works tomorrow? Tomorrow's, right before? Tomorrow's day 5, right?
Yeah, so we have lunch and then free after.
So you're free as 6 period tomorrow?
Yeah.
I'm also, well, I have class 4, 5, 6, 7, but period 6 would be a good period. I'd rather continue running to the test and break it up. Second half of period 6. Okay? Okay. Quick question, or you hang out? No. So people waiting behind you, we're waiting. Okay, so hang out for a little while. Gus, are you hanging out for a little bit?
I think so. I just need to find the
I'm going to call Robin and let him know you're hanging out, and I'm going to be up there for a minute.
Lily, are you staying?
Last questions? Yeah, probably.
Okay, good.
Oh, wait, never mind.
Because everything you're confused about, I'm probably also
Answer that. I have
You want to
to.
hang out still? You can go over stuff, we're just going to practice more problems with others, so if you have
I actually have until 8:5 this week. 8:7. Someone can't. 8:7 is fine.
you just pass this message along to Dave, that I know a couple guys, or a couple of 1 or 2 days.
I have 8 years so much
tomorrow and others, but I'll
Well,
be there.
okay. When I say 8:7, I mean 8:7 using the application. Because I mean, you're not doing it on its own, so you have an equation that you normally get in 8:7.
Okay, go check it out. But if you really need more help, it's
Yeah,
right
I just was thinking of using kind of like this makes sense when you use it on the calculator, it doesn't work, and I was like, oh, you can actually use normal math.
Yeah.
I have a tutor Mr. Howell tonight for a while, so
Okay, you don't want to hang out still?
I have to get home for him because I have to finish up.
See you there, Altan.
I have to, I have a lot of
Do what you
fun.
gotta do.
But I have a lot of study planned after tonight.
Okay?
Thanks, actually, there's a quick question.
Okay.
So just after you get your roots and
Mhm.
function,
Mhm.
you're just going to want to test all the numbers to find all the points you can.
Yeah, I mean, the whole idea is that you really want to test as much as possible. If you have like 5 roots, then it's really easy to graph because you know where they're going to be, right?
Yes.
But with only 1 root, you kind of have to just pick and choose. So what I was saying was, if you have a graph like this, you might want to choose like -2, -1, -5, maybe 1 and 2, and just run them through your original table so you can see what the values, the y values will be.
So yeah, you're going to want to test all the fields, things like X, E for both the problems.
You're going to want to what?
You're going to want to test all of
Oh, I did 8.
those values of X's after you get your function.
No. Those are the roots, remember?
So those are the.
So we know from this graph that because our other two roots, when you factor this, this becomes imaginary. These cannot be roots, so you're not going to test these numbers. You're going to test numbers that are appropriate. That's up to you to decide. So for me, appropriate for this, because I want to know the behavior in this area, would be testing points somewhere in here.
Oh, alright.
I want to see the curvature, so I need to know where my points are plotted.
Alright, that makes sense.
Okay, it depends on what the graph looks like, though. It's not the same for every example.
Okay.
Okay? All right. Those who are staying, some math, do some work. Good. Here, here's a book here for an
No,
example.
can we do actually an example from the homework, like just the first problem and go through?
From 8E, that worksheet?
Yeah.
Yeah.
Okay.
Do you want me to read it to you or have it?
If you have it, that'd be great, sure.
So u of x equals x cubed minus 2x squared minus x plus 2.
Okay. So, let's do this and let's talk about it together, and I want your feedback. So, first, what is the general shape of this graph going to be? Is it going to be up, up, down, down, or is it going to be rising or falling?
Rising or falling,
And which of the
it's
two?
gonna be rising because it's a positive.
Good. Is that agreeable? Yep. Okay. So I already know, before I even graph this, that I've got something like this. That's my first step. In my mind, or I just draw it. It doesn't matter either way. Okay, I start by either drawing my general graph on the right, and we'll fill in the blanks as we find out more information about this u of x function. Okay, good. Now, did I give you A, B, C, D? So what did I ask you for A?
Just Descartes for
To determine the positive.
All right, so Descartes' rule tells me, look for the sign changes. I've got one sign change here and a second sign change here. So there are two positive real roots or zero positive real roots. Remember, the number of sign changes indicates as most as I can have of that many positive roots. But I can always have two less. Because if I lose two roots, two imaginary roots. Always goes down by two each time.
How do you determine the negative?
That's when
That's
you
the
do
next
negative
step.
x, right?
So we want to look at, yeah, ask me.
So you do u of negative x. The reason why you would do that is so that you don't need to like figure out what the imaginary roots are. Like if you have two zero positive real roots and you haven't tested for whether or not they're negative roots, you just know that there are two imaginary, right?
Not necessarily. I mean, like, look, if we end up getting zero positive real roots, means that we gotta have two of these, or one of these being a root, and then the other two are imaginary. But it really just depends on the possibilities. So we do want to test this every time anyway. So u of negative x becomes negative x cubed minus 2 times negative x squared minus negative x plus 2. And when simplified, this becomes negative x cubed. But when I square a negative, it becomes positive still. So this doesn't change. But then this changes and this doesn't. So the easy way to remember it, Gus, because you were asking this, whatever's odd, right, the odd powers are going to change signs. That's all that really matters. Even steady. So we got negative, negative, no sign change. Negative, positive, one sign change. Positive, positive, no, so one sign change in this. So there will be one negative real root. And you are guaranteed that there will be one negative real root. Because I can't, remember, I can only go down by 2. So one negative real root. It's not like I can have 2 or 0, or one negative real root or negative. Who won?
You guys.
Did?
You
I
guys-
didn't
you guys
watch
pulled
any of the second half.
I just
It was
saw-
close
It was, and then you guys pulled away.
at the end.
Yeah, you guys just got high.
It was like a 2-point game
Yeah.
during the second period when I was giving a physics test, and I was screaming on my computer, and like, oh, and the kids all looked up. I was like, nothing, nothing. He goes to Providence, Villanova. We played today in Biggie Sport.
Yeah.
You guys killed Butler last
Oh,
night.
Wait, was that
Killed it. It was like
116?
80 to 50 something.
Yeah. We also did, like, we murked St. John's. When they came to play us, they killed them.
Oh, not. Oh,
But like, it was
Play
like one of
you.
the last game too. It was like one of the last games, yeah.
yeah, you guys are killing it this year. Is it Providence or
We're
is it
18
Marquette?
Marquette's the team.
Marquette's the team right now that's ranked higher than any other Big East team.
I think so.
It's
Villanova's
Marquette,
the West
Nova,
team.
and Providence.
What is Marquette?
Marquette's might be one.
Well, not the Big East. I mean NCAA.
Oh, I think we have Marquette. 'Cause
Yeah,
Marquette's good.
Marquette's ranked in the
Marquette's
NCAA.
good.
It's
It's
higher than
Marquette,
Nova.
Villanova, St. John's has a better record. And
Okay.
that's
Overall, right?
overall, yeah. We're 18 and 14. We're not.
So you're gonna get a bid for the tournament or no?
Probably not.
It would have to be a Big East win or something.
Because
right?
there's too many. Yeah, I think we're gonna take like 3 or 4 Big East teams.
Yeah, and that's a max. So this year they might not even take it.
Exactly.
Big East is struggling this year.
Yeah. But next year, I know next year, like, our team are gonna be good. Because, yeah, our guards are, they're gonna come out.
Nice. All right, I gotta continue because I gotta go to baseball.
I gotta
Good seeing you, man. Really good seeing you.
See you.
Come back soon to visit. for
Definitely,
Sure.
definitely.
All right.
Yes,
Keep us updated on all your awesome
I got you.
things in life.
I try.
Nice,
Have
Ernest.
you heard from Schubert?
No, not at all. Has not come back once.
Yeah, I know he's a pre-med student too, and I know that's.
I know, he switched, but still, give him a foot in the, get him over here.
I'll try to text him, especially after you guys just got.
And maybe give him a day or two so he doesn't give you any, strife.
Yeah, he ain't getting too much about OBJ. I don't even understand.
All right, later, Ernest. Thanks for coming to visit, Ernest.
Of course.
All right, cheers. He was the best.
What are you
He was so good. He was so good. All right, just a hard-working kid. Really works his butt off. So we have 2 positive real or 0, and we must have 1 negative real. So already, when we look at P over Q, we at least know that we have to test negative roots. Now, it doesn't mean that one of our P over Qs is going to work, though. Because remember, P over Q only give us what kind of real roots?
Real, rational.
Rational real roots, right? P over Q. But what if one of my roots is the negative square root of 5? That's a negative real root, isn't it? Because the square root of 5 is just like 2.2. So in reality, I can have a negative real root that doesn't come from P over Q. But chances are, P over Q will be useful to find a negative real root or some positive real roots. Yes?
But so if you asked us if there are any real if there are any real rational roots, and then if we got one that was irrational, we wouldn't have to.
Correct. So if you get a negative irrational, you're not going to be able to get it. How do you get a negative rational root?
Yeah.
No test for it. You only get the irrational roots when you get down to the quadratic level. When you keep going with depressed equations and subtables, when you get down to the quadratic, that's where your imaginaries or your irrationals are going to come into play.
Because in the problem set, I think it was in 8-7, there are 2 questions where you didn't have any
Rational roots at all?
roots, yeah. Or rational.
There
Were
were
you
2
able to get
questions where I was
those?
just testing numbers in the table.
And nothing worked?
No, there were 2. You guys get that too? Was it
For 2 and 6?
For, let me see. For 2 and 6, yeah.
You got what?
There were no rational.
Yeah, okay.
And that's possible. Was it just testing to find the roots for that question?
It was,
It wasn't asking you to graph, right?
No.
Okay.
But none of them asked
Go
us
to
to graph.
yeah, it said list the possible rational roots of each.
Yeah, so in those questions, sometimes you might not get any rational roots, and that's fine. But I'll tell you now, if you're going to graph,
You need that.
you need rational roots. Because without the rational roots, you're not going to have roots, you're not going to be able to find the depressed equations to get the irrational roots. So a graphing problem, I will guarantee you that if you need to graph f of x, like this whole 8e section, you will get some rational roots, at least 1. To get it down to a quadratic, or if it's x to the 4th, you'll get at least 2 rational roots to get it down to x squared.
If it's the non-calculator section, do you want us to still try to find like the min and max values? Like approximate?
Yeah, if it's a non-calculator, and in your graphing you're saying, you should definitely do it. Just approximation to get an idea of how far up that little loop goes or how down the loop
Right, but
goes.
when you have to plug it into like x to the 4th minus something to x.
No, you use a synthetic table. It's so much faster.
Oh, right.
Remember, synthetic table, you plug in x. What's the remainder really?
Oh,
The remainder is y.
Oh, yeah, y.
So if you want to get a coordinate for the little loop, just plug it into your original synthetic table.
Oh, right, okay.
So I'll do it for this one so you can see that, okay? You just coming a question about that?
Yeah, I have 2 things. One is
Gotta come back.
Okay.
This is more important. They have a test tomorrow. I'm sorry.
It's
Yeah.
like logistics though, because we don't have like any freeze together tomorrow. So could I come by like shortly after school? Or...
Figure it out. And another time. I mean, tomorrow I have baseball after school, and then we have a practice and a meeting. Email me tonight some suggestions, but I gotta continue here because I gotta go to practice and I'm late already. Okay? Hey, I hope you understand that, Riley. Normally I don't mind talking all day. Okay. So these are my headings across the top. Now the positive about this question is that look at P over Q.
Yeah,
It's pretty much just 2 and 1. Right? Everybody agree with that? Positive 2, negative 2. Positive 1, negative 1. So my P's over Q's are really nice to list. And that's it. Now, I want to use the intermediate value theorem and the boundary theorem if I need it. But those 2 theorems, remember, are not as needed on these problems if they don't appear. Right? if you don't get alternating signs, or if you don't get all the same signs, or if you don't get a remainder that goes from like 7 to negative 4, that'd be the intermediate value theorem, seeing that it changes sign. If you don't get that stuff, don't worry about it. Okay, you don't need it as much to graph this unless
That
it's
just means that it crosses the x-axis.
correct. When the remainder switches sign, it must have crossed the x-axis somewhere. That's the intermediate value theorem. So, what I want to test here, and I'm going to try, I don't know, I'm going to try 1 because 1 is easy. I'm going to try 1 first. 1 by 1 is 1. 1 plus negative 2 is negative 1. 1 by negative 1 is negative 1. Plus negative 1 is negative 2. That's going to be 1 times negative 2 is negative 2. Negative 2 and 0 is 0. So it works. Now, take a look. This table we're done with for the moment. Later, when we want to know those little peaks and troughs and stuff, we'll use this table again. But we need a new depressed equation. If that new depressed equation is quadratic, though, we don't need another table. If the new depressed equation is cubic, we do need to make a table. So, Gus, the new equation, is it going to be quadratic, cubic? What is it going to be?
It's gonna be
Look at your original.
cubic.
The original was cubic. Look at the original, Gus, at the top. So you go down 1, right? You go down 1 every time.
So it's x squared minus x plus 2. I mean minus.
Good. So there's my depressed equation. Can I factor it? Lily shaking her head yes.
Yeah, you get x equals 2 and x equals negative 1.
So x minus 2 and x plus 1 are my factors. I'm setting this depressed equation equal to 0 to do it.
So those are 2 roots.
So these are my other 2 roots. Because don't I have a root already?
It's 1, right? Yeah.
So there are my 3 roots. Now, at this point, you have so much information, actually. Once you get the roots, it's nice. And if you have multiple roots, it's really nice. So let's go to the graph at negative 1, at 1, and at 2. Let's put our roots in all 3 spots. At negative 1, at 1, and at 2. Do you notice? I did not label the y-axis yet. Can somebody explain why? Why didn't I put increments on the y-axis yet?
When you try to find the minimum and max, and you plug it back in, I guess you don't know what's the
Good.
thing about it, 'cause you don't know how high it's going to be.
You get what he's saying? So don't label your y-axis right away. Now, what's your y-intercept by default? 2. Remember, it's always a constant at the very end. The y-intercept, there's always this number at the very end. So the y-intercept is definitely 2. And that's a useful point. And actually, since that'll be right between negative 1 and 1, that'll probably be a max, right? So let's look at this together. Let's visualize this. I should continue to connect this line to my root because I know it's going to touch. It's not a double root. We had no double roots in this graph. So that means that this black line that I just drew will continue through the x-axis. It's not going to loop back, right? Now, because it's continuing through, take a look. This is at positive 2 here. So this is most likely going to be the max because it's right between my roots. So normally, like I said to you guys, you should test the point between your roots. But the only point between negative 1 and 1 that would be useful to test would be 0. And that is your y-intercept. 0, 2. You see what I'm saying? So if you test 0, you're going to get 2. So it doesn't make sense. But I want to test between here, which is what number? Plug it into this table and get the y value like this. Don't plug it into the original like you were saying, right? It's so much work. 1.5 to the 4th. And I don't use decimals here. I use fractions are much easier. So 3/2. So when I test 3/2 now, let's see what the numbers turn out to be. First, bring down the 1. 3/2 times 1 is 3/2. 3/2 minus 2 is negative 1/2. Take a look and make the work. Ready? 3/2 times 1 is 3/2, which is really 1.5. 1.5 minus 2 is negative 0.5 or negative 1/2. The reason I'm doing fractions is now I can just multiply my denominators. This becomes negative 3 over 4, right? So negative 3/4 plus negative 1 is negative 7/4. And then I continue. 3 times 7 is negative 21 over 8. 2 is really 16 over 8. You with me on that? So I've got negative 21 over 8 plus 16 over 8 is negative 5 over 8. So my y value is negative 5/8. That is negative 0.625. So this coordinate is 1.5 comma negative 0.625. And that tells me how low I'm going to go. It's like a limbo here. How low can you go? So we're looking here at 1.5 negative 0.625. So if I make this negative 1, then I'll go about halfway down. Here's my other point earlier. Go about halfway down and put that point right here. Okay, there's my other coordinate. And then I'll continue my graph. And I'll smoothly finish off the graph. Somewhat smoothly. I tried. Okay. So again, the process, what's nice about this is everything you did in 8.3 and 8.4, long division, synthetic division, you're using here.
Yeah.
8.5, remainder theorem, factors, you're using here. So really, if you could do 8e, you can pretty much do the whole test, right? If you can do 8.7, 8e, that kind of stuff. What's that? No.
I said saying a lot if you can do it.
Yeah, but it is the culmination of all the other sections, so it's pretty important to know.
So basically, like AP is just like everything from those put together.
Yep.
And then graph.
And graph. Yep.
I hate graph.
On the process, we have to get exact values because we just did eliminators with like rough sketches of graphs, not like,
For these,
No, for the problem set AE. Do you want like exact values?
you're talking about the maxes and the mins?
Because
Don't go back and do it again.
By the way, did we through all of
But in your
ABCD?
test, you should try to give peaks and troughs. So,
Did we go through all of ABCD?
let's take a look. It's really through. A, Gayberg's rules, number of positive and negative, good. B, rational root theorem for the list, you did, over Q. C, test some of the zeros, and use the intermediate value and boundness, if possible. But notice, guys, look, this didn't tell us anything. Only if all these signs are positive or all of them are negative, then this would be an upper bound. So the boundness theorem didn't play a role here, neither did the intermediate value theorem. Then what do I do next?
Be sure to test for repeated roots and determine all zeros of the function. That using the zeros and six graph. Okay, so
Yeah.
alright,
So
nice.
it seems like a lot because it's A, B, C, D, E, but I'm just trying to step you through how to graph. Now, I could on the test just say, here's a function, graph it. You should go Descartes, you should do rational root, you should test root, you should look for boundness, you should look for intermediate, you should get your, you follow what I'm saying?
Yeah, so pretty much like when we find the roots of the equation, it's not too difficult because you just find the halfway point and test it
Correct.
for x.
Correct,
So that's not
exactly.
bad.
Now, the end behavior, if you remember that, helps a lot too.
Yeah.
Because you get the general shape of the graph, right? This is a positive or positive leading coefficient or increasing function. Generally increasing. It decreases a little bit in the middle there.
Wait, what were you saying about middle point or something?
The test for peaks or troughs.
Oh.
Because I find the middle point.
I don't have
for
the
you
best
is-
math vocabulary.
It's
so,
excellent.
you know.
It works. Midpoint, middle point, something. You want to try one more with the fourth power, or you can go? You can go if you need
No,
to.
it's okay. I have to go.
Yeah, go.
Yeah, I can figure this out.
Yeah.
You sure?
I did all the
Baseball, I'm the coach, so we can sit here for an hour if we need to. But honestly, just, you know what they're doing? Inventory stuff. Getting the helmets together for the track, all that. We're not, we might throw a little bit on the roof and stuff after we do all that. So if you don't want to do all that kind of stuff right now, you can do this. It's up to you. I'm saying, you're not missing
Alright,
practice.
maybe we should do one more test one more then.
Look at that, ladies.
Yeah. Could you, actually, Josh, could you send me?
Yeah,
what's
I'll
that?
This is recording still.
Oh.
So I'm going to include it with the recording from today, so it'll go up in a little bit.
Oh, great.
Okay?
Thank you.
Yep.
Let us know, let us know.
Have a good night, ladies. What do we got for the next one, Gus? Just read it off to me so I have it too.
It is g of x equals 2x to the fourth minus 7x to the third minus 8x squared plus 13x plus 12.
This is a much tougher one, right? You notice right away? Because look at the P over Q's already, right? All right, no big deal. Let's go through it though.
Yeah, it makes it a lot easier when q is 1, right?
Yeah. When Q is 1, it's nice because then it's just P. Yeah.
Okay.
Yeah.
So first we find sign changes. Right?
Correct.
So there is 1 between the 2 and the 7, 2 between the negative 8 and 13, think that's it.
Good. Agreed. So what can we state?
So, and then it could be equal to 0.
Good.
for roots. And then, so you would put g negative x on negative.
Correct.
So negative 2x to 4.
Careful. Remember, what did we say? Just negate all of the terms that are
Oh, x. Okay.
that are
Oh, that are odd degrees.
Good.
Okay, so it would be 2x to the 4th plus 7x to the 3rd minus 8x squared plus minus 13x plus 12.
good. How many sign changes in this one?
You got one between the 7 and the negative 8, and then another one between negative 13 and negative 12.
Nice.
So then you have 2 negative rows.
Yes, I put positive. I meant negative. Thank you. Or
0.
okay, that's part A, Descartes' rule signs. Part B says to list all the
Rational zeros.
okay.
Okay, so is this what P of Q comes into place?
Yep. So P over Q, we got a lot of them here, right?
Yeah.
I would do all of the P's over 2 and then all of the P's over 1. Since Q could only be 1 or 2, right?
Okay.
Because P could be multiple things,
Yeah.
right?
So P over Q would equal first either one to be plus or minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1.
And then do all of them except?
Except 2 over 2.
Yeah, 2 over 2 is not going to be, or yeah, exactly, except change the bottom of that. But yeah, 2 over 2 will not work. So we start with 2 over 1.
Yep.
Sorry, we start,
Oh, no.
sorry, we start with 1 over 2, right?
Yes.
Because we're changing the denominator now.
Yeah.
But then when I get to the next one, like you said, it's 2 over 2, which we don't need a new one for,
1, so then 3 over 2,
which is new.
4 over.
We already have it, right?
No, we're not.
Good,
We already have 6 over 2, so
good,
and we're at 12 over 2.
good. So I put them just so we see it, but yes, you don't have to know the text, not going to listen. So really, what's nice about this is they're all integers except for 1/2 and 3/2. So that actually makes it a little bit easier. And I would recommend on the test, don't test the fractions.
Right away.
Test the integers. And even if the integers don't work, you might get an upper bound or a lower bound or something to help you navigate your search.
Is there any suggestion for which ones to test for a faster approach?
Not really,
Is it
unfortunately.
Just test the one in between to cut off some.
That's what I would choose. I would personally test 3 or 4 first.
Okay.
Either positive or negative, but I would use like 3 or 4.
I guess just 4.
Okay?
4 and take 2, -7, 8, positive 13, positive 12.
Okay.
So you carry down the 2, 8 minus 7 is 1. 4 minus 8 is -4. -16 plus 13 is -3. And then 4, -3 is -12. Oh, look at that. Ah,
Nice work.
nice.
Good choice. Now, hypothetically, Gus,
Yeah.
had we tested, let's make believe we tested 6. I just want to prove a point here, okay? So let's just run 6 through. We didn't really do this, but make believe.
Yeah. 2, 6, 12, minus 6, 5. 30 minus 8 is 22.
What's happening? Do you have to go any further? 6 times 22 is going to be big, right?
Yeah.
And then you're adding 13.
Oh. Okay.
And then 6 times a big number is more positive. You're adding 12.
I never really thought of that.
See
You
that?
did that in class the other day.
So what do you notice? They're all positive, right?
Yeah.
And if you test a positive and they're all positive, it means that that number is a
Irrational. No. Upper bound. Upper bound.
So upper bound means test all the roots lower than that. So by seeing that 6 didn't work, we can also rule out 12.
Okay, makes sense.
Since this is an upper bound, nothing above it will work. That's what it means, upper bound. So let's cross off 6 and 12.
And that would be the same for if there were -6 and -12, or no? No.
No.
Right.
So the negative side we have to consider still. So technically I should still put -6 and -12 as options here. On the negative side, Gus, the only time we can get a lower bound is if we test the negative number and we get alternating signs, all 5. And when all these signs alternate, it means that the negative number you tested is a lower bound.
Okay.
And then you only test numbers above that since it's a lower bound. And an upper bound, you only test numbers below that.
Okay.
Okay? Now, again, we didn't test 6, so for the sake of this chart, I don't really need it, so I don't want you to get confused. I'm going to put a line through it, really. But again, you can test whichever numbers. Now, Gus, once 4 worked, what should we have done?
Do you take the depressed equation and then
Good.
start testing values again?
So this becomes 2x to the what power?
Third. And then minus 7x squared.
No, careful. Use the numbers in the row, not the heading.
Oh, right. Plus x minus 4x minus
And do I need a remainder?
no,
Because it's
0.
yeah, and that's the whole idea. So this is my new depressed equation, and it's cubic now because my original was to the 4th power.
Mm-hmm.
So my goal now is to figure out the roots of this depressed equation in a new table. Now remember that the y coordinates we get from the new table are not useful unless they're 0. You remember I talked about that?
Yeah.
So if I wanted to know, like for example, say our roots later turn out to be 4 and 3, right? And hypothetically, let's say I tested 3.5 in here.
Mm-hmm.
The y value I get is not the y value we're going to use for the graph. Because this is not really the original
Yeah,
function.
you
we
can plug it
tested.
back into the equation.
Very good. So what do you want to try next? We found out that 6 was an upper bound, so we're not going to test 6 or 12.
Okay, so maybe 3.
Couldn't 4 be a double root, maybe? So you always start with the root that worked.
Okay.
Does that make sense?
Do the double root for the
Yep.
graph.
Always test for double root, for multiplicity. My header is 2, 1, -4, -3. I'm testing a 4 again.
8, 9, 36, minus 4 is 32, 4 times 32.
Doesn't matter,
I guess not.
right? Just do this, right? So what does that mean, guys? Look, they're all positive. What does it mean?
It means it's not about.
It means 4 is an upper bound of the new function we have, not the original. Because remember, 4 worked in the
So then
original,
we
didn't it?
can, well, we can't really cross out anything else. 'Cause it's
No,
not.
it's been limited, unfortunately. But we get that idea, right? Remember, 4 is an upper bound of the new function, not the original.
That makes sense. Okay.
So what do you want to test next?
Maybe 2.
Okay.
Okay. So then 2, 4 is 5, 10 minus 4 is 6, 12 minus 3 is 9.
All positive again.
So,
So do I need to test 3?
no, because
Good.
you can
2 is another upper bound, right? Good. So keep going now. I'm running out of room. I'm going to zoom out
Yes,
a little
test
more.
1.
Yeah, sounds good.
So then 1 times 2 is 2, plus 1 is 3. 3. -1. -1 minus 3 is -4. So that means
Ooh, interesting. What's going on? Our remainder went from being positive to negative. It means,
we can't use the lower bound.
no, a lower bound only occurs when you test a negative number and these signs alternate here. But when my remainder goes from being positive to negative, it means that this is like a y value that's positive. Think of this coordinate 2, 9. Visualize it in your mind. Visualize where 2, 9 is. Here's the origin.
Yeah.
2, 9. Agreed? Where's 1, -4?
1, -4.
So doesn't this graph have to cross the x-axis to connect these 2 points?
Yes.
So somewhere between 2 and 1 there must be a
Root.
So what number is between 2 and 1 out of all my options to test?
Oh, 3 over 2.
There it is. So
Ah.
that helps you to figure out. Now, 3 over 2 might not work though. It might not, and that's fine. If it doesn't, all that means is that there's a root between here that's irrational if 3 over 2 doesn't work. Because remember, 3 over 2 is testing a rational root. So if the rational root between here doesn't work, then you guarantee yourself that there is an irrational root between 3 and 2. Or between 2 and 1. I was using 3 and 2 because 3 halves. So let's try 3 halves then.
So 3 over 2 times 2 over 1 is 6 over 2, which is 3, plus 1 is 4. So it'd be 6 minus 2 is 2.
Careful. Do it again. It is 6, but it's not minus 2.
Minus 4, which is 2.
You said 6 minus 2 is 4.
Oh, that's what
I got you. As long as you, yeah. It's,
so then, so it'd be 6 again. Wait. Yeah. No. It'd be 3 minus 3 is 0. So then that's a root.
and again, like we noticed, because this sign changed between 2 and 1, it meant using the intermediate value theorem, we were able to recognize, hey, there's probably a root between 2 and 1. And this, we use the upper bound, right? We recognize this is an upper bound.
Yeah.
Okay, both of these are technically upper bounds, actually.
Yeah.
So we've got our second root. Let's circle our roots in another color so we keep track of where they are, right? So far, 4 and 3 halves. Now, at this point, Gus, should I still use synthetic division?
Because you can write it out into a quadratic function and track it.
2.
So 2x squared plus 4x plus 2
Equals.
equals 0.
Good.
And then, so you use AC method? No?
You could, but aren't they all factorable by, or factored by? Aren't they all multiples of?
2.
So divide the whole equation by 2.
Okay, so then it'd be x squared plus 2x plus 1.
Good.
0.
Which factors into?
There's multiply by 1, add 2, would be negative 1. I'm struggling with this right now.
That's all right. So remember, whenever you do these guys, you start with the c value and just think of the factors of 1. It's 1 and 1 or negative 1 and negative 1. That's all the options are.
Yeah.
And does 1 plus 1 add up to 2 or negative 1 plus negative 1, right? That's how you have to think about that each time.
I never really thought of looking at factors.
Always start with the factors of c. And whatever the factors of c are, if they add up to whatever b is, then you know you have the right factors.
So then negative 1 is a double root.
Well done. Yep. So how many roots do I have at this point?
3.
Careful. 4. Good. Because the double root counts twice, right? So I'm done finding my roots with this problem. I'm completely done finding my roots. There was x to the 4th, and I have all 4.
So we do 2 positive roots and 2 negative roots.
You
So
picked up on that, right?
in theory, if there was like more than that and we would have 4 right now, we would have to keep testing.
Correct. If it was x to the 5th or x to the 6th as a degree, you'd have to keep testing. But
Yeah,
like
that
you
would make
said,
sense too, because it would keep, we wouldn't have factored it.
correct. We would have another subtable. And notice, like you said, for Descartes, it worked out nicely, right? Descartes said, hey, it's 2 and 2, or 2 and 0, or 0 and 2, or maybe no real roots at all, they're all imaginary. But chances are, if I'm going to ask you to graph it, you're going to have a couple real roots, at least 2. You know what I'm saying? Like, why would I'm not going to graph something with all imaginary roots, because you can't graph it. You would have no x-intercepts at all, and it might be a function that's like doing all this weird stuff, and it's above the x-axis. You can't do anything with it. So let's graph this now.
So our roots are 4, 1.5, and then negative 1.
And what do we want to keep in mind about negative 1?
It's a double root, so it would not.
Not
I'm
going to
not gonna say this.
the graph won't cross the x-axis. It will be tangent to the x-axis.
Yeah, because okay.
Now, based on the degree and the leading coefficient, is this graph going to be up, up, down, 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 up, down? Good. Up, up. So already, Gus, do this. Ready?
So the endpoints are going up.
Like that, right?
So,
Throw your arrows up. Now again, you just told me what's going to happen at -1. Is he going to actually cross the axis?
So it's gonna just like.
Yep, very good. Now before you keep going, what's the y-intercept? Go to the original.
The y-intercept is gonna be 12.
So let's make 10 on the graph so we have at least that much, right? And let's put a dot up at 12 here. And let's smoothly connect here and come back around. So far I know that much, right? And that's all I know so far. Now, what's a halfway point between -1 and 1.5? Maybe something in here you want to test? So give me a value.
0.5.
Yeah, let's try 0.5. Where am I going to try to get the y value? Where am I going to test 0.5? In here, there?
The original.
Always the original. So let's run 0.5 through the original up top. We might run out of room for that, so I'm going to do it over here on the side.
2, 7, 8, 13, 12. Okay, so then you bring number 2. So that would be 1 minus 7 is -6. -6 over 2 is -3. Minus 8 is -11. -11 over 2. It's going to be 5. -5 and a half.
Good. Plus 13.
Plus 13 is 8. So, yeah, 8 and a half. No.
You went up, go down. From 8, you went up a half, you got to go down a half, right?
Oh, 7.
Yeah, there you go. It's just going to get messy, unfortunately, you know?
Yeah.
Now, 7.5 as a fraction is 15 over 2. I think it would be easier to write 15 over 2, actually, because when you multiply it, it's a lot easier.
Yeah. Whenever I do this test, I always do it by hand and always.
Well, don't forget, like, if I give you a calculator, you can test stuff in there also and just use a table instead of doing synthetic division every time.
Oh, so like the problems like these, well, wait, no, you won't.
You may or you may not. I may give you one with a calculator and one without a calculator to see both skills, because I want you to be able to use your calculator. It's very useful, but I also want you to be able to do it by hand.
Mm-hmm.
So you could expect a problem of this type for a calculator and a non-calculator.
Mm-hmm. Okay.
Okay?
So then,
But if it's calculator, you put the original in y1, and you could just have a table of values and use the table function instead.
So then it would be 15 over 4
Plus 12.
24 over.
12 is 48 over 4, really, right? So 15 over 4 plus 48 over 4.
Is 63.
Nice. Over. Good. And 63 over 4, reasonably speaking, is around 16. It's 15.75. So let's go up to about 15 on my y-axis now and put another increment. And let's put a coordinate up here somewhere around 0.5, around 15.75. So I'm going to make believe that that's the max for now, because I don't know if it is or it isn't without some calculus involved. So that's all I'm going to say for that one.
And then you can
Now,
go down.
Good. Loop it back down to that one. Good.
And then we get to test again for between 0.5 and 4. So.
And this, I mean,
3 maybe?
so this is, well, careful. This is 1.5. So that's 2, that's 2.5, that's 3, that's 3.5. So yeah, 3 works. Let's try 3 because it's easier to try, right?
So, 3, 72, so 6, 7, -1, -3, minus 8 is -11. -33 plus 13 is going to be -20. -60 plus 12 is going to be -48.
So what do I have to do for this part? I got to go really far down, don't I? So in reality, I mean, I should just make this guy -20 instead. I can do that, right? I'm allowed to. And my point's going to be all the way down here. Oops. Down at -48. I'm running out of room, you know?
I didn't graph the negative y-axis, I just put -15 at the bottom.
That's fine. Yeah. And it's somewhere down here, right?
So then it was 3, -8, and then so the graph looks
Yeah, and every time you reach a max from in, try to make it show that it's curvature.
Okay.
Okay?
Alright, this isn't too bad now. This was good.
So just practice. I mean, you have 4 more examples. I would highly recommend doing at least numbers 3, 4, and 5. 3 and 4 for sure. 5 and 6 get really tough. Just because I'm just pushing you
Isn't
guys.
this tomorrow anyway?
This is your homework?
Yeah, this is it.
Yeah, that's what I'm doing. What I'm saying, when it comes to focusing for the test tomorrow,
Yeah.
3 and 4 for sure.
And I also have to do the problem set for AD too. I did everything else,
Okay.
so I
So
can.
that'll be a lot of practice.
A lot of practice for
And AD is literally the entire test for tomorrow. You know.